Good morning, everyone. Today we will be discussing the last topic on this in this module of analytical chemistry and dealing with gravimetric analysis. So far in this particular module, we have been looking into only the qualitative analysis and the connected terminology. So, in the last topic, we are going to now look into the quantitative aspect of the analytical chemistry. So, in that, one of the important techniques that we use, apart from the titrations that you have already done in your practical classes, is gravimetric analysis. So, gravimetric analysis, the basis of quantitative measurement here in the case of gravimetric analysis is mass of the analyte. Okay, so this particular way of determining the amount of an analyte present in a sample is completely new to you, because in titrations what have you have been using was directly the concentration terminology instead of the mass terminology. So here you would be actually quantitatively measuring the mass of the analyte. So there are different types of gravimetry being used in various applications. So we have some major ones like precipitation gravimetry, volatilization gravimetry, electrogravimetry, thermogravimetry. So I've written down the definitions here. So precipitation gravimetry, if I would like to tell you what it means, it basically means it here whatever the analyte is there in the sample which you need to measure is actually being converted into some form of a precipitate, okay, by addition of certain agents, precipitating agents. So by measuring the amount of the precipitate, you would be able to find out the amount of the analyte. In volatilization gravimetry, as the name suggests, here you heat the sample, and whatever volatile materials present in that sample would be evaporated. So on the basis of loss that is happening, you can find out the amount of the analyte that is present in the sample. Basically, this particular term is gravimetry is used for measuring moisture content in a particular given sample. Electrogravimetry is another type of gravimetry, which here we actually determine the concentration of metal ions in a sample, because here we use electrolysis. So during electrolysis, the metal ions present in the solution get deposited at the cathode. So thereby, by measuring the weight of the cathode of the electrolytic compartment, you can measure out the amount of the metal ion present in the given sample. Thermogravimetry is almost similar to volatilization gravimetry. Only difference is here we keep on heating the sample, and here we just not worried about the volatile ingredients of the sample, but here it will undergo a complete decomposition also, and we keep on heating until we reach a state where there is no more change in the weight of the sample with heating. So this is another way of determining the composition of a particular sample. So we have different forms of gravimetry available for measuring out analytes in different samples. So in your syllabus, we have only the precipitation gravimetry, but if you would like to know about these gravimetry, I have put some book pages which you can read. Apart from that, you can look into the quantitative analysis by Vogel, practical quantitative analysis by Vogel. That book describes about these instruments. You can read about it and you can have a knowledge about that gravimetry. So let us try to define what do you mean by precipitation gravimetry. So in precipitation gravimetry, an insoluble compound forms when we add a precipitating reagent or a precipitate to a solution containing our analyte. So while I was discussing the definition of the precipitation gravimetry in the previous slide, I told you that here what we are measuring is the precipitate of the analyte. So how the precipitate is forming? By addition of certain precipitating reagent, or they are also called as precipitant. Let us understand this a little bit diagrammatically. Suppose you have a solid analyte. Okay, you are given a sample in which is solid in nature. So the first thing that you have to do if you have given a solid analyte is that you have to make a solution of it. So the first step is dissolution. After that, what you do, you will add a precipitant or a precipitating reagent. So what happens when you add it? The analyte in that mixture, in that solution, would be precipitated. Then what you do, the next step is basically the digestion. So when you add the precipitant, you get the analyte being precipitated. Okay, so you allow the sample for digestion. Now digestion is a terminology which is used because digestion means you allow the precipitate to stand along with the mother liquor for some time. So what happens when you allow a precipitate to stand along with the mother liquor? There is a constant dissolution and reprecipitation, constant dissolution and reprecipitation. So because of that, this particular digestion process is usually done in order to remove certain impurities that could come in the precipitate. So after digestion, for some time, what you do is you will do filtration using Buchner funnel. You will filter it, then you will dry the sample in oven, and then you will ignite the sample. Sometimes we do ignition because drying alone won't remove the moisture content, because many of the moisture content would be trapped inside the lattice points of the crystal precipitate. So we need to remove them. So that can be removed only by ignition. Finally, after the complete drying, and we made sure about the purity of the precipitate that is formed, we will weigh that precipitate, and from the weighed form, we will back calculate, because we know exactly the formula and the composition of the precipitate. So from that, we can back calculate and find out the amount of the analyte present in the given sample. So as you can see, we have a lot of steps involved in this particular analysis of the analyte via precipitation gravimetry. So this gravimetric process in as such is very laborious method. Like when you are going to actually do this kind of analysis in the lab, especially you're going to start with something that is determination of concentration of barium chloride or something like that. What you will find that you will do a lot of step, and it's not as simple as titration. But the beauty of this particular methodology in quantitative analysis is that it is very, very accurate compared to any form of quantitative analysis that you know of. The most accurate one, if you want to say, is this gravimetry. So that is why still people use quantitative gravimetry for doing quantitative analysis, because it gives more accurate results. Okay, so that's why this technique is pretty important, because many of the standard measurements that comes is on accounts of these uh, gravimetric determinations. So the precipitation gravimetry is based, here we have two important things that criteria that we need to keep in mind, because as we have seen that here basically what we do is we will completely convert an analyte into a precipitate. So this precipitate is very, very important in the case of precipitation gravimetry. So the property of this precipitate, be it the physical, chemical, or any other aspect that is connected with the separation of these precipitate. All this is important because this, if any mistake is happening in this area, then the whole analysis can go wrong. So that is why there are this two criteria is based upon the nature of the precipitate. First is the physical and chemical aspect of the precipitate. Second is the technical aspect of the precipitate. So first important criteria is that the precipitate must be of low solubility. That is important because if your precipitate is showing some kind of solubility, then obviously your results won't be right. Then it should be of high purity, obviously, because if you have impurities coming into the precipitate, you will have wrong weights of the precipitate, and that would lead to wrong results. Finally, you should be aware of the composition of the precipitate because you should know exactly what your precipitate is made up of. That means you should know the exact chemical composition of your precipitate. Only then you can back calculate accurately the analyte mass. So these physical and chemical aspects of the precipitate, you should be pretty much careful in precipitation gravimetry. Secondly, the technical aspect, that the precipitate that is formed, which is of low solubility, high purity, and you know exactly the composition. Now, the second technical thing that you need to remember is that they should be able to be separated from the reaction mixture pretty easily. If that is not happening, then the whole gravimetric analysis would be going wrong. So apart from the physical and the chemical properties of the precipitate, another important factor that you should keep in mind is the separation, that there should be a easy and convenient way to separate the precipitate from the reaction mixture. If the precipitate is somehow having a nature that is not suitable for separating them out, suppose it is a kind of very colloidal kind of thing or agglomerated kind of thing, then it would be really a problem for separation. So that is very important, that the nature of the precipitate should be such that it should be easy to separate them from the reaction mixture. So let us take some example. Suppose you are given a sample in which you are asked to calculate chloride ion, which is your analyte. That is what you are going to analyze. So you are given a sample in which you are asked to calculate the amount of chloride ion, which is your analyte. So how would you go about it? You need, in precipitation gravimetry, you need to precipitate that chloride ion in some form. So usually the thing that we use here is precipitate them as silver chloride. For doing that, you need to add some silver nitrate. So when you add silver nitrate, you will be knowing about, you will be precipitating them as silver chloride. So this is how, so once silver chloride is formed, you will dry it, you will ignite it, and ultimately you measure the amount of it, and from this you know that 1 mole of silver chloride is equal to 1 mole of chloride. So how much mass of silver chloride you got, from that you will know how much mass of the chloride ion would be present in this particular sample. So this is how you do the precipitation gravimetry, and this is the method that we use for the purpose. So in the live session, we would be discussing more about it. So just to go through whatever I have said now, just recollect it. From here, we will try to go into more of the aspects of the precipitation gravimetry. So for now, I'll stop here. Thank you very much for patiently listening to the same. Thank you very much.